Hello everyone and welcome. Today we will try to implement a Z shell or ZSH that will work in our terminal and allow us to have some simple interpretations. This will be a simple Unix command interpreter project, like there's examples like bash, ZSH, or sh or other command interpreters. For this video, I will use GitHub code spaces so everybody can follow along. It will be in C language, and I will start by choosing a blank template in GitHub code spaces. It will take a minute to load. Okay. I will choose dark modern theme. That's what I am used to. And we can start by creating our main file. And now we have our main.c. Of course, we want to have recommended extensions for our VS Code. While they're installing, we can start by including std io.h, and let's think about the steps we will take. We will want to have a loop, a shell loop that will stay open in terminal so we can put inputs and use it as a shell. Then we will have input parsing. We want to parse the input from the terminal so we can execute accordingly. We will have some comments that will be built in. I would say we can implement cd pwd echo set env on set env which and exit. These will be our built-in comments. Let's say built-in comments. Then we will need to execute external commands, and we will manage and find variables. We will manage paths, and we will do some handling. So these are our main objectives of this project. We can start by creating our main function. And I don't know if you are familiar with C, but we usually have two arguments that we have in the argc and char star argv for our main loop. But for this project, we will have a third variable called char star env. This will give us the environment that we will work on. Okay, we will not be using argc and argv, so I will just say it here. We don't need our argc and argv, so we can start by implementing our shell loop. For this, I will call a function called shell loop, which will receive our environment variables, and let's the function shell loop, which will have char star open to env. So what we want to do is we want to receive the line from our terminal. So I was planning to use getline function for this purpose. We will have a variable called char star input that we will store our input variables. I will call it null for the beginning. We will have a size variable called input size that will be 0 as initializing it. We will have char arguments, char star arguments, which will be a loop we will be checking. And we can have a while loop, while 2, 1 is like to declare. We will have the getline function. Getline will get line to our input. We are giving the address of the input that we created as a variable. We will have address of the input size. And of course, we will get the data from std_in, so we are also adding it. Now we have our getline. What will be smart is to check if we are getting the line, which also in part of error handling, but we will do it in a moment. First, I want to see if we are getting the input from our terminal, and we want to be able to end this loop, so we will add another statement for that. But for now, let's see if we get the input. Using a printf statement. Let's gcc main.c. Let's execute. When I put a line in the terminal, we can receive it, and we have it in our input, and we can print it back in the terminal. I will just Ctrl+C and get out of the program. Now, to be able to fix the loop, we can put this in braces and add a statement at the beginning. And we can just say -1. This means getline function will return -1 only if it is end of the file. Or AOF, it will return -1 and we will break out of the loop and keyboard also it will mean Ctrl-D. If this statement is correct, we want to break out of the line. I will just GCC again our main and check. I give some text, it gets getline, it gets the line, and it shows me at my input. And when I press Ctrl-D, we are out of the loop and stop executing the program. Okay, now we have our getline. Let's continue our second step, which will be parsing the data we are receiving. And we will continue by parsing. Before starting to getting the input parsing, I want to add two simple extra simple. One will be error. If there's a error with our getline, we just want to see that we get error in getline. So I am adding it while we are here. If we have a getline in the problem, it can be end of file or there can be a problem with the failure of getline function. It will print error. And another thing, as you can see, when we are in the loop, we don't see that we are in the loop. So it's for usual purposes only, but why not? I want to have with our loop, I want to have a string calling like my shell, and this way it will look nicer in the terminal. Let's try to GCC and work terminal, and you can see now it says my shell. We can give inputs and it looks cooler. We will give it some commands like cd, ls, and if you have multiple different inputs, it will need to parse it. And even if I say something like echo, like our pets, we will want to be able to see there's an echo command that we will need to take care, and there's a pet, so we will need to parse it, and then we will start handling the data we parsed. Now we can start working our input parser. In our loop, we already have our input that we know it's working, so I will just comment it out. Let's call a function in our shell loop that when we get the input, we will basically parse it. I will call it parse input, which will receive x, which will receive the input as input, and it will return to x. This way, when we have the input, we can parse it and have it as args and continue executing. So now I will create a new file called in parser.c, a new C file. I also want to have an H file so we can connect these C to be able to connect these C files. I want to have a H file. I will call it my shell.h, and here can include my shell.h. We don't need this here. Let's paste it here. Input parser. Let's call our shell file. In the main, we made a parse input. We call the parse input function, but we don't have it yet. So it will receive a char style variable and it will return a list, not a list, the array of the char. So we declare it in our H file. And we can start implementing our input parser. Basically, when we receive the input, we will have tokens, and we will need to store the tokens in our string array, in char array. Also, we need to clean for empty spaces or tabs or other unuseful data. Also, we will have a max input variable I will define here, which I will say 124 for now, so we know we will not have problems allocating memory later. We will create a buffer, and I will say buffer size equals max input. The type, let's fix it. We will have a chart type tokens that we will have the values and that we will return tokens. We will malloc it immediately because we are using C and we always need to allocate memory for the functions we are using. It will be the buffer size times size of char star. We will malloc this twice. This was the first one, which will get enough buffer size for our char star. And we will have char star token, which we can initialize it null at the beginning. Also, we will have an integer, or let's say the size t for our token length, which will be 0 as initializing, and we malloc the tokens, so we can start by controlling if malloc is working. If tokens is okay, we will, if the tokens is not allocated, if it's null, we will print error saying malloc, which will print error of the malloc, and we will exit the loop saying exit failure, and we don't have exit failure, so we will call it in stdlib include stdlib.h. Okay, now we have our exit statement. At this point, we will basically make loops. I will use a for loop that will check what is in the input and tokenize it. So let's say for size ti, it will continue as long as we have data in input. And we should make some error handling, but I will leave it for now. Let's keep simple at the moment, then we will add error handling options. So we can start by saying token is equal to input of I. So we are basically saying our token is the address of the input I we are at that moment. And then we will calculate the length of the token. As long as we have the input of the I, it is not, it is existing, and it is not an empty line, and as long as it is not. Okay, for now this is enough, as long as it is existing and it is not an empty space. We will want to get our token length. We will increase our token length. Also, we will increase the I, so we can move one token length when we are done with this. And then first we need to set the I will declare another variable for seeing which token we are at. In which token from the tokens we are at. So I will call it size t position, it will be 0 for the beginning. And for the position that we are at tokens, we will need to malloc it. And malloc, I will give it the token length of the token plus 1 for end of the file times size of char. Because of this is the inner char style, you just need to multiply it by char. That we malloc our tokens, we will have another while if loop check if we initialize it correctly. Same as this one, I will just copy and paste it for now. If tokens position is not mallocked correctly, if it returns null, it will print error and it will exit using exit failure. Now that we have our tokens mallocked, also we mallocked our token positions, let's copy the token into the array of tokens. So I will take the for loop. We already use size ti, so I will call it j. That'll be an inner loop, and it will be j++. And now we know our length. The length we have to go is token length. So as long as we are in token length for each position of the tokens, and token length for j. So for each position, we will get the char one by one. I'm not using str copy or something like that because this is C and we don't want any sec faults or memory problems. So I'm just using a for loop. It might not be the best case use, but why not? So this will be our token. Basically, we are getting the position of the token and copy it in our tokens char by char. Tokens position and token length is, so we are basically saying for in tokens for each position of the token we get the length, and the last value will be the end of the, it will be null terminating token. I think I should make more comments so people also can understand, right? And when we are done, we will move to the next position, and we want to clean our, reset our token length for the next token. And we can get out of our for loop. And before returning tokens, of course, we need to say tokens position, which will be the last token position. And we will also call it null So we will also terminating with null array, terminating the array with null, null. So we will not face problems. I believe this should be working. And we made our parse input function. Let's see if it will work. In our main function, we have args, and after parsing input in our input parser.c file, we should have the arguments as we expected. So I will say printf args and args. But because of this is a args will be a double pointer, so it will be in an array. We will want to have a for loop of each element of our array. As long as we have our args I, we want to print this thing. So let's GCC. Of course, we cannot GCC anymore. At this point, we will have to make a Makefile so we can execute commands as we can execute the files as we need. So I will create a Makefile. You can copy and paste any templates from Google or internet or other places. We will have main.c and our parser.c for now. Also, yeah, let's have these, but eliminate them later. Not on G, it's objects, so RPG. We will CC by GCC, of course, we are doing C programming. Some basic stuff. I will say CC. We will have user and flex, so we will create object files which they will receive the target. They will create object files. We will have clean option in our Makefile, so I will say we will clear the object files. We will have fclean to remove everything. Clean plus we also remove the target. And if I go there, I will clean all. This should be a good enough Makefile for now. So I'll say make and it works. Let's say my shell. We have my shell. I give it the inputs and args are input I give. Oh, let's print a new line. after this. So my shell args will be first, second, third. As you can see, we had our input. Now we get input. We are parsing input in our parse input function, and we can print them successfully in our terminal. So the next step will be command execution. We will talk about how we can execute the commands, and we will be doing our built-in commands, and we will continue soon. Okay, guys, we passed our input, and it's working. So let's comment this printf out. We can continue executing commands. We will, in our while loop, we see that our input is parsed in arguments. So first, as long as our args is not empty, which can be possible when if the user enters a empty comment, we will call our shell built-ins, which we will give arguments, and v and environment, and we will also have initial directory that we will need to give our shell built-ins. So initial directory will be our directory that we are working on. It will be needed for like when we call commands like cd. We will need to know our directory so we can work on it. It's getCVD function when we call getCVD function and don't actually give it anything. We'll testing getCVD C. It will use unistd.h. I will add this to my H file. All you need is like a buffer and size t size. It gets the absolute path name of the current directory, and you can Google and check all the time when you need to see the details of the function. So we called an initial directory char*, just think in other languages. We just get cv and we give it null and 0. So we know our initial directory or cd or some simple commands we will need. So we will need a shell builds function. First, I will declare it in our page file. It will return an int. It will receive char** arguments, char** nv, and char* initial directory that the directory we are in. So actually we can just create this function here. Let's copy it. So our shell built-ins will be echo. So yeah, this the list I gave before. These will be our shell builds, and we will create comment functions for each case. We can check. We can use a switch statement to see which argument we receive from our shell loop. When in our shell, let's say we want to call echo pet, the first argument will be the echo, which will be our comment that we will call according to first argument. We will call the function we need to, and then we will give it the pet as an argument to that function so we can execute the command. And let's make our shell builds. I noticed that we forgot something quite important. I don't know how I forgot this, but as you know, in input parser, we are looping to each character and we are mallocing them in two places, but we are not filling them when we are done with it. So I will create a new function. We will fill tokens. We can just, it will be a void function. We call it fill tokens, which will see char star tokens. And as long as tokens exist, if they're not existing, it will just return. Else, we will play them in a for loop. Size ti tokens I plus plus. For each, we will fill the token. Index of I. Each token. And then when we are done filling all individual tokens, we can fill the tokens array. And of course, we need to add this to our H file. So, parsing input, we are also filling, and in our shell loops, when we are done using tokens, the arguments in this case, we will call it free tokens, and it will receive the arguments that we received from parsing input. We will use them in our data, and when we are done with it, we will free them so we will not have any seg faults or memory problems in the future. Okay, now we can continue our shell builds. I notice another error. We say if arg0 equals null, which we don't want this, it will be the opposite. If arg0 is not equal to null, or we can just say if not arg0. So if it's not null, we will call our shell builds, and basically we will have a comment handler for each case. Even though I'm not a fan of stink library, I will use stink.h for this part. Stink.h header, stink header. I will say strcompare. We will compare args0, we will see, and we will check if it is cd. Then we will call cd as if. We will check again str compare, which will check x0, which will take x0 and compare it with next variable, which is pwd, and it's just I am using Shift, Alt, and down arrow. Copy it. We will have 1, 2, 3, 4, 5, 6, 7, 8 arguments. So 3, 4, 5, 6, 7, 8. It's too much. It seems too much. Okay. Okay, I don't want to handle any values here. Maybe, I don't know. Let's see how it goes. So first one is cd, pwd. We'll check for echo. We will check for env. We will check for which. I know it's C, but it's too long, so I will make some format changes. We can see everything in smaller spaces. Okay. Let's say if it's CD, we will want to call, let's see, command CD. And for command CD, we will need arguments of it. And like this, we will needing couple comments. We can call yeah, we can just call it built-in function implementations, which will not be that simple task, but we will implement each variable one by one. For example, we will have command cd, as I said before. I am not doing set env and unset env yet because we will be dealing with env at later point. Oh, also we want to have what we want to have exit. We will have an else statement which we will do later. It means it built in comment. Now we need our shell builds. For each function, you can Google them, seeing what they do, but like cd changes the directory, pwd shows the current directory. I can just show here when I say pwd in my terminal, it says we are in the workspaces and in a blank code space, which is correct. When I say echo, it just echoes what you give. If I say env, it shows the environment you are in. If I say which, doesn't give anything because we also need a variable for which. Let's search which comment. So we can call something like which ls, and it will show you the ls you are using, which is in US users bin ls. So to implement these functions, we will need different arguments for all of them. As you know, our axure will be the command we want to apply, and the second and third, or whatever the number, we will give it to the function we want to work. So we will have init command cd function, which will return, of course, the arguments, and it will also need initial directory. Next function will be the pwd, again another int command pwd. In this case, it will not need any arguments. I think this is the best one. And we will have another command echo. It will be an integer. Echo will need char star arguments and star environment which we are in. Next one will be env. Again, another int command v, which will be needing environment suggested in the name. Next one we will have which. Again, int command which will need char args we will give, and char star env. If you are curious why I give arguments in like which, as you can see, after calling which in terminal, it will not give you anything if you don't give it an argument. In this case, I give ls, so also the function will need to know which argument it will work on. Also, it is working on environment, so you also give it env. And for env, you don't give any comments, as you can see. here. It just needs to get the environment to print the data. For echo, of course, you need to give an argument, an environment it will work on. And for PWD, you don't need anything. It will get the environment it's working on by itself. And CD will need the argument that the directory you want to change and the initial directory we are on. And these are the comments we will work for now. And then we will working on another comments for set NV and unset NV, which they will return char star star. Other than this, because we will need to know what are they returning, which we will implement them the latest. But we are not in a hurry. And of course, same as the others, they don't need anything extra. We will just give them the arguments and the environments we are on, so they can set and unset it, as the name suggests. Okay, these are the comments we will be implementing. After calling command cd, now it knows what we want to give it. We will say arguments and initial directory. Also, these are integers, so we can return 0, 1, or -1 when we are done with them. So because of this is an int function, we will return whatever this returns. So if there's a problem with the command cd, it will return 0, 1, -1, whatever, and we will know if there's a problem, where to find it, or what's the problem. So let's continue. Command dwd, it doesn't want anything, my favorite. We will have command echo, which we will give arguments, and we will give environment. We have command nv, which is looking for the nv. We have command which will ask for arguments and environment. Lastly, we have exit, which we don't need any extra function. We will just say exit and exit success. Also, I might call it exit or quit, maybe, depends on the user. But if it is exit, or let's say str compare x 0 quit. So in this case, we will know if we can check both exit and quit. So we have a little bit more function, more flexible. This is our program. We can do whatever we want to do. So you can even say random words to exit the program or do another this. I'm just trying to stay focused and loyal to the original ZSH. It's until some extension, of course. It's still implementation. And we can start working our unique implementations. And so, yeah, we are moving on our to-do list. All right. Before finishing the first part of this video, I want to create a new C file called helpers.c, which we will have our helper functions. I will have it so, because I told you before, I don't want to use str functions, but we did. So I will take strcompare and I will implement my own version. So I start by including my shell.h. My str compare function, which will receive through constant chars star. It will be str1, and we will have another constant char str2. We will compare this sticks or char pointers, and they will return 0 if they're both equal. They will return less than 0 if they're if str2 is shorter than str1, and it will return greater than 0 if the str1 is greater than str2. So we will have a while loop, while star str1 and star str1 equals star str2. Plus str2 plus plus. So basically, we will check if str1 is existing, and if it's existing, we will check if they're equal by char to each other. We will check the pointers for the strings, and then we will return pointer to the, we will check unsigned char star str1, and then we will check unsigned char star str. So if they are equal, it will return 0. X are equal less than 0, str1 less than str2, if it's bigger than 0, str1 bigger than str2. Now we implemented our strcompare function. Okay. Now we can change strcompares. I will use Ctrl D to select multiple of the same text, and I will just say my strcompare, and when I say make, it should working, but it doesn't. Or that's because we need to include std def.h. Let's say make again. Problem undefined defense. Oh, okay, that's because we forgot to have it in our. Let's see. It's the problem now. Command cd. Where's command cd? It's here. Hmm. Can comment this out. These two, these two, these two, these two. Make and call my shell. If we only have exit implemented at the moment, so I will type exit and it's not working. That's because, as you know, if they are the same, it will return 0, but in this if loop, we are checking for if they are the same. So before this, we will need to say not. Now it should work. Let's see, make. It's called shell. If I say exit, it doesn't exit. So quit, it doesn't quit. So, oh, so this one. Shell exit quit doesn't work. Why? Hmm. I will find my error probably in a second. Okay, let's go a little bit old school. If this equals 0, equals 0, so make shell exit, still not exiting. So let's check our arguments that we receive in our shell builds. Let's say printf r 0 is x 0 right my shell exit. It doesn't say it. Are we click on shell builds? Yes, if x0 not existing, I'm making a mistake here. Let's see. If x0 exists, it will be 1, and if not, that why do we have a mistake? Say make my shell exit, and x0 is exit, but we are not exiting. Why? Make a mistake in my str compare function? Maybe that's a possibility. X0 is exit. We can set here, and it's supposed to exit. Oh, that's interesting. Let's say another print statement here. I'm exiting. Let's And we will need a new line after this. Main my shell exit. It called exit. It gave us a new line. We didn't even need a new line. It was already had a new line after the exit. But we are not reaching. I am exiting. I wonder why. Let's do some quick debugging. strcompile via our str1 and str2 is equals, and we will turn I want to try quickly if our strcompare function is working or not. But if arg0 equals exit, let's quickly have a test for our my strcompare function. I will say char str1 equals abc, char str2 equals abc, the result equals my strcompare str1 str2, and we will print f result and d result. Let's make my shell d, and the segmentation fault. I wonder why. By control D, we exit our loop by success in this line. And when we return to our strcompare, we had a problem. So I guess we made a mistake on strcompare function. Okay, why not? Okay, I'm gonna try the string version. In that case, we will need to include string.h. We will say main, I shall control D, and we have another segfault. So, what's the problem? To the loop, we're having a segfault. That's interesting. Is it because of this? Control D, and yes. So when I try this, there's a segfault. I don't know why, but this is programming in C. Of course, we will face segfaults. We can have some C-flex. Well, so it will compile by CCC, and we also added now C flex, C make again, hypo, make, woohoo, a favorite, unused parameter in line 14. So I will call it void and we also save it initial directory. And of 24, we will return exit. I think we can return exit success. There's no problem. Now again, make my shell exit, and it does exit. Huh. But it does. Okay, now it works. If I and comment this, will it work too? Okay, that's weird. When I exit by Ctrl D, we are causing segmentation fault because but it didn't also print exit. Oh, I'm exiting. It does quit. That's interesting. I will stop calling the loop and just try to and we make my shell and we have result 0 for str compare. So my str compare and have a new line so it can be cleaner. My shell result 0. So my str compare is working. If I say ABCD, make my shell result -100. If I say ABCD and ABC, make my shell result 100. So my stack compare is working. There was no mistake with that part. I don't know why it didn't work when we first tried. We don't need this. Gonna delete. We're calling the loop. Inside of the loop, we are getting the arguments, parsing them, and then we are calling them in our shell builds. And if the arg0 them stay, if arg0 is make my shell exit yeah equals 0. Make my shell exit, it exits anyway. So I guess that's because Yeah, also getting this. Shell builds. We can make shell builds. Turn a value. Exit success means 0. Not again. Exit and exit. Parenthesis. I feel like I am focusing on this too much, even though I don't need to. So I just want to see that it's working and it's returning value we are expecting it to be. But make, of course. Make my shell cd argument cd and we're exiting anyways. So I would say we are having problems with my str compare. I will try just str compare. My shell cd seems like whatever input I give, we are exiting without printing the statement. This is because of the exit function, maybe. I will say return 0, make my shell cd arg cd. We are receiving the argument as cd, that's good, but when we are comparing with our str compare, it returns 0. Make my shell cd exit. I know that we are getting to the shell builds function and we are printing the argument 0 we are receiving, and we are comparing the argument 0 we received with the comment we are looking for. Oh, now I see the problem. We have to fix the tokens that we are receiving in input parser, because you don't see it, but what we receive is not just cd. What we receive is cd and new line. So if I were to say cd and new line, this time look printed. So okay, that's good. At least now I know the problem, so we can fix it quickly in the input parser. Before looping and getting the tokens, we need to check if we have white space characters. So beginning of the for loop to check skip leading white space characters while input I equals empty, or I equals new line, which was our case. Let me think. We will check for empty character. We will check for new line character. We will check for tab character, and then we have return character, and we have alarm character that we will need to check for. So if input I is empty space, or it's a new line, or if it's I equals T I equals what's next? R, or lastly put I equals new line alarm. So if our input I at the moment is equal, what's the problem here? There's a mistake. Why there's a mistake? Oh, I put the while loop in the wrong position. So if the input I we are checking at the moment is empty space or new line or tab or return or alarm, we will just skip that line, and as long as we are skipping the white space characters, and if we skip them, we will then also need to check for if we are at the end of the file. If input I equals the file, then we will return. We will back out of the loop, and then we get our tokens. We are checking, and then while we are calculating the length of the token, we will also need to add another checkpoint. We check if input I existing, not end of the file, it means. This is the same as this one. If it is not empty space, and then we will need to add these other conditions too for error handling purposes, I will say. And these, and we can change this for statements to ends. And now we should have our fixed parser. So make my shell parser exit. We are still not exiting. Why? If I say cd, that's something different, because now we will need to print what we parsed again. Make my shell, let's say cd, argument loop is empty. Why? We made a mistake somewhere. Let's find it quickly. We are checking tokens, input. We are checking if input is empty or new line. This stuff should be fine. If input is End of the string, end of the string. We are breaking, and we are. Oh, I see. You should check for not equals, but we are checking for equals, so I will fix it quickly. If input is not one of these, then we will continue. And let me again. And cd, we print cd if I say exit. We print, don't print exit. Let's see why. Because my str compare is not working. Let's say my str compare, so we know it works with str compare. By this we can. No, it's working. So exit. Size exit and okay, I know my str compare is working, so I will not doubt this again. We are checking. If this is 0 and not 0, it will be 1. I think I have an idea of the problem. Yeah, also check if not equals to end of the string. Let's see if this was a problem. Exit quit. Okay, arg0 is quit. Shall loop after we check the arguments we give. I say cd, it's working. So maybe this is a problem. Here my str compare. If it is plus 0 or not, we will check if it was 0. See, make my shell cd works, exit doesn't work. Why? They are the same. My str compare cd. Okay, let's start pwd. Print f pwd and new line c make my shell pwd, and it also doesn't print because check my shell pwd, it prints pwd. My str compares. If it goes 0, it means they're equals, which I will fix this quickly. That. C make my shell exit. I am exiting finally. But my shell, if I say quit, it says I'm exiting. It's supposed to exit successfully. So let's see if it's working now. When I say exit, I said I'm exiting and it exits the loop. So we can delete the printf statements. We saw it's working. My str compare is working. I can delete this string header. I hate strings, and it seems like stuff is working. we can comment this debug option out. We are good to stop for this part of the video. On the next one, we will start building our built-in comments. We will start by this. And thank you for watching. See you on the next video. Bye.